So ammonia forms addition compound with water. Ammonia plus water combine to form NH4OH. So you can also write the same reaction in other form, NH4OH aqueous reversibly gives NH4 plus aqueous plus OH minus aqueous. Okay, so we have very less ions and most of the NH4OH remains undissociated molecules in the form of undissociated molecules. Okay. Okay. Now, if you say this, in the forward reaction, water donates proton to ammonia and ammonia accepts proton from water. So water is acid in this reaction and ammonia behaves as a base. Now you must not use this word water is an acid, you must use the word water behaves as Bronsted acid. When I say water behaves as Bronsted acid means according to Lorentz-Bronsted theory, water is an acid, ammonia is a base. Means now you can recall that theory and say, when I say water is Bronsted acid means water has a capacity to donate H plus ion. When I say ammonia is a Bronsted base, it means ammonia can accept a proton from water. Got it? Fine. And in the backward reaction, कौन proton donate करे से कौन proton accept करे NH4 plus donates a proton to OH minus ion. Okay, so when NH4 plus loses a proton to OH minus ion, we get ammonia and water backward reaction. હવે forward ઓછું થાય છે અને backward વધારે થાય છે. Forward માં water proton donor છે અને backward માં NH4 plus proton donor છે. તો કોણ better proton donor હશે? NH4 plus is a better proton donor. Proton એટલે H plus ion as compared to water. Forward માં કોણ proton accept કરે? Ammonia accepts a proton. Backward માં કોણ accept કરે છે proton? OH minus. Forward ઓછું થાય છે અને backward વધારે થાય છે. તો કોણ વધારે strong proton acceptor હશે? OH minus. So OH minus ion is a stronger base as compared to ammonia. Ammonia is a weaker base. Got it? So you can compare relative acid strength and relative basic strength. Fine. Okay. Now we'll introduce two terms that are related to this. In any of the reaction that you see, we have two acids and two bases, like what we discussed just now. In the forward reaction, HCl is acid, as it donates a proton. In the backward reaction, H3O plus is acid. Okay, so let me clean it up. I think you all must have written this. Okay. I'll write one of the equation again and explain what I mean to say. So let us write one general reaction. HA is any acid. It can be HCl, it can be HNO3, it can be H2SO4, it can be HBr, it can be HI, it can be H2S, it can be acetic acid. So this is general formula of acid. Okay, we are interested in this H and not what is the rest of the molecule. So HA is general formula for any acid. Not necessarily it is monobasic acid. If I एक H हो जरूरी नहीं, but there is at least one H that can be given to a base that can be lost. Okay, so HA is general formula of any acid. Okay, so we get H3O plus and A minus. So now we'll write HAXS, HAXS, acid. So we'll write acid below it. Water, this loses a proton, right? So water acts as base. Now in the backward reaction, this is acid as it loses a proton, and A minus is a base. Now HA after losing a proton forms HA proton lose करे गुजराती में तो શું બનાવે ફટાફટ સમજાઈ દે. So HA after losing a proton forms A minus and water After gaining a proton, forms. So as you can see, we have two acid-base pair. This is acid and this is its conjugate base. And this is a base and this is conjugate acid. બંને એકબીજાના conjugate acid base pair છે. ઓકે, તો હું એક સમયમાં મેથ્સ ભણાવતો તો મેથ્સમાં કન્સેપ્ટ આવે કોમ્પ્લિમેન્ટરી એંગલ. તો કોઈ એક દિવસ મેં કીધું કે ભાઈ કોમ્પ્લિમેન્ટરી એંગલ ઓફ 30 ડિગ્રી, 30 નો કોમ્પ્લિમેન્ટરી એંગલ છે 60. પછી કોઈ વખત બીજા લેક્ચરમાં એમ કીધું કે ભાઈ 60 નો કોમ્પ્લિમેન્ટરી એંગલ છે 30. તો એક સ્ટુડન્ટ કે સર એક ડાઉટ છે, કોમ્પ્લિમેન્ટરી કોને કહેવાય, 30 ને કે 60 ને? So both are complementary angles of one another, each other. એટલે આ એસિડ છે અને આ એનો કોન્જુગેટ બેઝ છે. તમે એમ કહી શકો આ બેઝ છે અને આ એનો કોન્જુગેટ એસિડ છે. બંને એકબીજાના કોન્જુગેટ એસિડ બેઝ પેર છે. નામ છે કોન્જુગેટ એસિડ બેઝ પેર, conjugate of each other. Similarly, we have one more conjugate acid base pair. Clear? So હું તમને એમ કહું કે મને HA નો conjugate base આપો, તો it is A minus. તો તમે કહી દો શું? remove H plus ion. તો HA નહીં, હું તમને લખતો જઈશ. તમારે મને આના conjugate base આપવાનો છે. તમારે કરવાનું શું? H plus remove करना. And when you remove 5 હોય એમાંથી +1 remove કરી નાખો તો ઓલામાંથી માઈનસ કરવાનું એટલે 4 આવે. So if you remove H plus ion from HNO3, you are left with NO3-. So NO3- is conjugate base of HNO3. તો આવું આપણે લખતા જશું. હું એસિડ લખીશ, તમારે મને એનો conjugate base. Okay, so CH3COOH acid છે તો એનો conjugate base CH3. આમાંથી H plus ion remove કરો. Okay, H2S HS minus S2 H2S માંથી H plus remove કરો તો એક H બચે HS minus, અને HS minus માંથી if you remove one more H plus ion you are left with S2 minus, right? Okay, few more. Carbonic acid, remove H plus ion, HCO3 minus, and practice HCO3 minus CO3 2. Few more. અને હવે વચ્ચેથી જ ક્યાંકથી આપણે ઓકે એવું ન કરો. ચાલો H3PO4 નો કોન્જુગેટ બેઝ H2PO4 minus H2PO4 minus નો કોન્જુગેટ બેઝ HPO4 2 minus, અને HPO4 2 minus નો કોન્જુગેટ બેઝ CO4 3 minus. So chemistry is very easy, right? So these are the problems that will be asked at the board level questions. Okay, no one is going to ask you this in JEE or NEET. Okay, so बहुत simple questions here, simple, but we have gone through many examples. Need a few more or this is enough? Fine. Okay, seeing this example, water acts as a base in forward reaction, and હું તમને એના conjugate acid ની formula પૂછું તો તમારે એમાં H plus add કરવાનો. Opposite of what we have done. We have many examples written on the board. NO3 minus is a base. Conjugate acid of NO3 minus is? So add H plus ion, we get HNO3. CH3 minus is a base. Conjugate acid of CH3 minus is CH3 is equal to HS. HS minus is a base. So conjugate acid of HS minus is H2. And HS minus is also acid. Conjugate base of HS minus is C. HS minus, like water is amphiprotic. Water can give H plus ion, water can accept H plus ion. Similarly, HS minus can accept H plus ion. When HS minus accepts H plus ion, it behaves as a base. It forms H2S. And when HS minus acts as an acid donates a proton. So when it loses a proton, we get S2 minus. Show me one more example of amphiprotic substance. It is this. So HCO3 minus can act as a base. It can accept a proton to form H2CO3. And HCO3 minus can act as an acid. It can give H plus ion, lose H plus ion and form CO3. So कोई तुमने conjugate acid पूछे तो तुम શું કરશો? Add કરશો. याद केम रखते हैं? कोई तुमने conjugate acid पूछे तो तुम add करशो H plus ion A. So if I ask you to give me conjugate acid, you add H plus ion. So if I ask you conjugate base, you remove H plus ion. Easy? Very easy. Okay. So this type of stuff can be asked. Now, okay, it seems that we have explained. Now, Laurent-Brunstad theory is a broader concept as compared to Arrhenius theory. Okay, HCl gas combines with ammonia gas to form ammonium chloride gas. This can be explained based on proton transfer theory, but there is no water involved in this. Okay, so this is a neutralization reaction, but this cannot be explained according to Arrhenius concept, because according to Arrhenius, neutralization is a reaction when an acid in water, this is acidic solution, this is aqueous solution of acid, this is aqueous solution of base. When they are mixed, H plus ion derived from acid combines with OH minus ion derived from base. Okay, so very familiar example is HCl aqueous plus NaOH aqueous gives NaCl aqueous plus water. Okay, so when an acid and base react with each other in water, then it is neutralization reaction according to Arrhenius concept. But we also know that neutralization occurs even in gaseous state when HCl gas combines with ammonia. So Laurent-Brunstad theory is a broader concept as compared to Arrhenius concept. Got it? Now, why was a need for another concept of acid and base? What was the need? So come bijo concept I wrote, so there must be some drawback. Okay, so do you need to note down or you have already written? Okay, so you can pause the video and that is okay. That is okay. Fine. Now I'll show you one acid-base reaction where no proton is involved. So limitation of Laurent-Brunstad theory is that it needs a proton. Still there is H plus ion involved in the definition. That any substance can act as an acid only if it has a proton in it. And any substance can act as a base only if it can accept a proton. So I'll show you one reaction. You know this substance is basic in nature. and you know that this is acidic compound. So when CO combines with SO3, we get what we get? So CaSO4. So similarly, CaO can combine with SO2 to form CaSO3. આ બંને acidic છે. From the previous classes, you know that sulfur dioxide, non-metallic oxides are acidic in nature. So SO2 and SO3 acidic substances છે, acidic gases છે. And calcium oxide quick line you studied in S block. Okay, क्या calcium oxide basic છે. તો એનો મતલબ આ પણ acid base reaction જ છે, પણ આમાં તો પ્રોટોન છે. એનો મતલબ something is missing. Okay, so G and Lewis in the same year 1923 માં Lorentz Bronsted theory was given. In the same year this theory was given and an electronic concept of acid and base. Lewis name we have also come across in chemical bonding chapter that I taught you, right? So dot and cross structures, Lewis dot structures. Okay, so he studied electronic configuration of these substances and observed one thing. Okay, let us take one more example from the Lorentz Bronsted theory, and again to emphasize that two persons can look at the same thing and see it totally differently. Ammonia is a base. Ammonia is a base according to Arrhenius concept, and ammonia is also a base according to Lorentz, as it accepts a proton. Now, when any substance accepts a proton, proton doesn't have any electron. ભીખું છે પ્રોટોન, એની પાસે ઇલેક્ટ્રોન નથી બોન્ડ બનાવવા. So when any substance accepts a proton, it will have at least one lone pair of electron, lone bonding electron pair to donate, and this is the definition of Lewis base. So Lewis base is any substance that can donate an electron pair. Lewis base is any substance that can give an electron pair. So when ammonia accepts a proton, it donates its electron pair to form a coordinate bond. તમને ખબર છે H+ ion combine થાય તો નાઇટ્રોજન સાથે coordinate bond બનાવે. Coordinate bond is a bond that is formed between two atoms by sharing an electron pair that is contributed by one of the atoms but shared equally by both. So here nitrogen contributes an electron pair for the bond formation. Okay, so this is the definition of Lewis base. Lewis base is a substance that is electron pair donor. And you have come across this word in your organic chemistry chapter. Any substance that can donate an electron pair is called nucleophile. So Lewis bases are also nucleophilic substances, nucleophile or nucleophilic substances. Okay.